In software engineering, we are discussing about the quality concepts. So, risks. When we make a software and when the software is responsible for people, that is, we already seen about people betting their jobs, comfort, safety, entertainment, the decisions, even their lives on computer software. So we need to be very sure that the software is right. In medical field, in aviation, in maritime, everywhere we have software. I'll give you an example and just imagine what can happen. Throughout the month of November 2000, at the hospital in Panama, 28 patients, this is the hospital, Gorgas Hospital. Here 28 patients received massive overdose of lethal gamma rays during the treatment for different kind of cancers. And the month following, 5 of the patients, they died from this radiation poisoning. And the radiation poisoning, 15 others developed very serious complication. And why this was happening? This is the example of a bad programming. So what caused this tragedy? Errant software can actually kill you. So a software package developed by a US company, and it was modified by a certain hospital technician to compute the modified dose of radiation for each patient. And 3 Panamanian medical physicists who actually tweaked the software to provide additional capacity were charged with second-degree murder. Second-degree murder. So you can imagine what can happen if the software is not good. The US company also faced serious litigation in 2 countries. So, poor quality led to risks. Some of them very serious. Killing people, killing us. So, software can kill you. As a software developer, you need to be very careful about this thing. We always have a hierarchy in companies. So we have a management, big boss, then people who decide. Then comes the moderate level people like the program manager, program leader, and software coder, tester, etc. So software quality is influenced by certain things like the technological decision. But more than the technological decision, the software quality is affected, influenced by the management decisions. What management are taking different decisions. Are they wise? Are they rational? Are they legal? Right? So those people who are actually taking the decision are very different from the technological decision. So it can be for good, it can be for bad. Even if team is better, software team, the management decisions influence. The project leader, for example, they make certain decision, and that can good or bad impact on product quality. I'll give you a certain example. Estimation decisions. So how do estimation decision, they affect the software quality? A software team, it may not be, that is, I'm talking about the moderate level people. So they may not be that much involved in estimating the delivery dates and overall budget. Only the big bosses, they decide. And when they're asked, the team will just conduct a sanity check. Whether these delivery dates and milestones being given in front of them, are they rational or not? Are they good or not? Means this is just a sanity check. No mathematics, no computation. Just say, oh, it seems okay. But when the actual scenario comes, when the pressure of delivering the software comes, they accept the unrealistic, not achievable delivery dates. This happens in almost every software because now the delivery dates have come and the budget is over exceeding. So now the team takes shortcuts, and when you take shortcut, product quality is bound to suffer. So this is how estimation decision affect scheduling decision. Schedule means what will happen when, after which, and what should be the project plan proper. So a software project schedule, when it is made or established, tasks are sequenced. They are dependent also. So they are based on dependencies. If something will be done, then other thing will be done like this. I'll give an example. For example, A depends on B, C, D. Component A depends on B, C, D. So until B, C, D is done, A cannot be checked. So A cannot be scheduled for testing or other purpose until the components on which it is dependent, B, C, D, are fully tested. So many cases, pressure forces, that is the delivery date, the budget, all these forces A to be tested even before B, C, D are being done completely. We may use stub, the seams or hooks. So this can be done. But A may have those defects because when it is combined with B, C, D, that is not checked. So these errors, bug, problems will be only uncovered when B, C, D will be combined. So they are discovered much later. And you know the consequences? Quality will suffer. Quality will degrade. Now coming to risk-oriented decision. The top bosses take certain decision, and what they normally do, as everyone does. See, no one says they are going to die, but everyone dies. For example, if you want to go from say place A to place B, have you ever thought my tire will burst, or the road will be redirected, or there will be an accident which can cause some casualty? We never do that because we think that nothing will go wrong and we never make a contingency plan. This happens in every field, even in the software industry. We don't plan. Many teams, they would like to prefer blind optimism. That is, they want to establish development schedule under a clear assumption that nothing is going to go wrong. But when risk becomes a reality, there will be chaos. And after this chaos, quality suffers. The level of quality invariably falls. So there will be chaos. If something happens to you on road, there will be chaos. If your tire get burst, there will be chaos. Now here, Jim Maxim, he said something which everyone knows, everyone has been saying, because he said, so now it is a law. There is never time to do it right, but always time to do it all over again. That is, if you are doing some assignment and you do it hastily, quickly, but when you go to the teacher says, no, these 3 points are not, you have not done it seriously. Go and do it again. You'll go and do it all over again. But when you are doing it for the first time, you're not interested because you thought, oh, let's push it. The teacher, let us see the teacher. There is never time to do it right, but always time to do it all over again. How to achieve this software quality? There are certain ways, there are certain facts, methods, because all these attributes can only be achieved by a proper plan, organized thoughts. So management and the practice, they are applied to help software achieve high quality software. So what do we apply? Software engineering methods. This we apply. Project management techniques. This we apply. Because scheduling, PERT, CPM, quality control actions, quality assurance. So all these are applied to every work product, to whole software development life cycle. So let us start with the software engineering method. SDLC, software development life cycle, you choose prototyping, waterfall, spiral, agile, whichever you want. So the basic idea is to completely understand the problem. And then you have to design comprehensively. So a proper understanding, getting the requirement, knowing the requirement, designing it, this will be a solid foundation for construction, for coding, for testing. So when you do this, the quality of the software is going to increase, and it will increase substantially. The second thing is project management techniques. Now your project manager or the leader, there are certain ways, there are certain good ways, already laid down de facto. The impact of poor management decisions on software quality, how to avoid them. We need to adopt certain things. That the project manager should use estimation to verify the delivery dates, which are achievable, which are not unrealistic, which are so that the software team can do it with quality. Schedule dependency, that is one product, one part is dependent on another. This has to be understood. And the temptation to go shortcut, to do it fast, to just deliver, should be avoided. Proper testing, proper verification, validation should be done. Risk planning, that is, if you plan the risk, you have the contingency plans, you have identified the risk, there will be no chaos, and software quality will not be affected. Along with this, the project planning, the management should include the explicit techniques for achieving the quality, the change management, the configuration management, the testing, different types of testing. Coming to quality control. This quality control, how do we control the quality? We need to have certain way. So this quality control are all the software engineering actions which we have learned to ensure that each work product, it can be a software, it can be a document, it can be other work product, they should meet the quality goals being assigned or being decided before we go ahead. Models should be reviewed. It can be requirement model, it can be analysis model, it can be design model. All these models, the test cases, should be complete, should be consistent, and it should go through multiple reviews. So this testing should be applied because we need to uncover the errors, bugs, problem in the processing logic, in the data manipulation part, in the different interfacing, because the experienced people know where the error may lie, where may the problem may lie. So this testing has to be done methodically and with best brain effort. So the combination of this measurement and the feedback, this is done when any work product fail to meet quality. If quality is not there, just do it again. Plan, do, check, act. Plan, do, check, act. PDCA. PDCA. This is the Deming PDCA cycle I am trying to show. This is how we achieve software quality by quality control, right? Quality assurance. Quality assurance means we are assuring that this product has quality. Who is going to assure? Of course, the top management. So quality assurance is the software engineering method, rational project management methods, the quality control. All these are applied again in a proper managed planned way. That is to assure that the quality is there, and this will make a high quality software. So this quality assurance, it has auditing, it has reporting. So here we assess the effectiveness and the completeness of the quality control actions, right? So if the quality assurance shows some problem, identifies some problem, now this is the management responsibility to address this problem and to apply and provide the necessary resources to resolve the quality issues. So quality control, project management, software engineering, all are applied, and this is called as quality assurance. If you see here also, production, baseline, system development, release, market, all are there in the quality assurance. This is all about quality. Thank you so much. Take care of yourself.